Hello, 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 everybody. This is Cloud Hudson back again for today's weather tonight. It is Monday, January 8th, and we are just waiting for Tuesday to come. Uh, I don't know why, but I just got this feeling that Tuesday's going to be big. The earthquake. We're gonna try something new today. We're gonna start from the earth and go out. So, so as to keep my news stories straight in the headlines. I guess if I'm starting from the center of the earth, I should start with the volcanoes. Where was that? No, I didn't have it pulled up. Let's just skip it. Well, I guess actually I'm going to talk about volcanology at the end here with the Rearcast Peninsula stuff. I'm going to be let's go back to here. So first of all, this is just showing earthquakes from yesterday. Hey, what is that earthquake near me? What? Okay, because earthquakes, this is around Columbia, South Carolina. That's not that weird. We see them there sometimes. This says Tennessee. 3584. That's right at the tip of North Carolina. So this is where, well, okay, it's at this inflection point of, you see like the bend in the ridge here. This is like North Carolina's tail end. This is also in a very powerful spot energetically in the mountains. Is this like near Kyoto? Where is that? No, this is even west of the Great Smoky Mountains National Park. Yeah, so that happened today at a depth of 14 kilometers. Magnitude 2, though. I think this is near like Robbinsville, Lake Toxaway. Let me see if I can. Weird. Well, that's not really the most significant earthquake. Let me stop being centered here and not centered on myself. We've had earthquakes rippling all across, just basically tremor size and shallowness. Maybe a 3 down in Southern California. This area of Texas has been popping off all year. And still getting some rumbles down in Puerto Rico. I noticed Puerto Rico had on Epiphany on the Day of the Lizard Kings. It's a holiday. January 6th is a holiday down there before the other stuff. It's been erupting since January 6th around here. Or not erupting, earthquakes have been going. But really, what we've got is here in Indonesia, the Telad Islands, Indonesia. And then, is this another shallow? Oh, that's not too shallow. Again, continued 4s at 10 kilometers depth, all along where we first saw that Honshu. We've got 4.5 at 10 kilometers, 4.4 at 10 kilometers, and 4.4 at 10 kilometers. That 10 kilometer 4.4 is rumbling through here. And where else? I wanted to talk about the Bellini Islands. Yeah, let's do that. The other day, we had a swarm of eruptions around here too. So if we're going by the transforming convergent faults here, those ones that are pushing next to each other, you imagine if you're pushing next to something and it shakes, you're going to shake a little too. And that shaking just keeps going down. Really surprised we haven't seen anything up here yet, but perhaps all of the energy that would be going to moving the whole plate is going into filling up the magma chamber under the Reykjanes Peninsula in Iceland right now. That's my conjecture. But anyway, you're not here for conjecture. You're here for me saying what for sure happened. We do have some deep earthquakes here. What is that called? How do I click on this to get it? Let's go back to the list. I don't know how to get back to the list. Okay, where's that very deep one? Yeah. Fiji Islands region. Is that this? Yeah. Yeah, that's the Fiji Islands region. You see Dutch Sense talk a lot about what the shapes of the underwater ridges and troughs here mean. I'm not going to, I'm not conjecturing. I'm observing. And to me, what I observe here is that the pattern looks like a wave. Like it looks natural to me because this is the type of sharp angle that you would get in a wave that's going like, you see how my hands are almost in a right angle there, even though the wave is curling itself down. Like imagine that this hand is the underside of the wave and this is the overside of the wave, and you can picture an ocean wave. A wave that breaks curls down, but first it has this sharp angle in it. And I think that all of the tectonic plate shapes that we're seeing are the angles coming together, waving and crashing really slowly over time. So as I zoom out, I think maybe we can see we're not really seeing the plate boundaries. Let me see. Show plate boundaries. Yeah, you see it even better with this because like this yellow line is convergent. That's the underside of the wave going like, boom, it's pushing up. And then this one is heavy on the top. That's what this other yellow is from. It's going like this. And then in between, we've got that deformation region of transform and divergent boundaries, because within the spiral, it can't just collapse. All the collapsing goes against itself. And the way that the wave breaks, this is the wave breaking. Eventually, those yellows are going to smush up together. But right now, we've got pulling apart and sliding next to each other. The blue is sliding next to each other. So you can almost see like a spiral of blue that's going side to side. And this is your spiral going away from each other. Anyway, I think this is one of the Fiji Islands is one of the clearest examples that there's no, that the shapes that we're seeing in the shapes of the fault lines are tracing out moving, crashing waves of earth waves. And I'm not talking about resonances, like electrical resonances that go through the tectonic plates now. I'm talking about the wave itself is the plate. The whole plate is actually fluid and moving on a really large time scale. I don't know what else could seem more clear than that. And if we look at it, this is like going like this. So right hand rule, it's sucking up out. But we're in the southern hemisphere. So we're going like that. Left hand rule, right hand rule. I don't remember. But I don't know. I would think angular momentum of a earthquake that's happening right here would be sucking it out. Let's animate these earthquakes and see what they went through. So are they getting deeper as they go? It's kind of hard to say. That's this one. Yeah, they're like, it's just all rattling around here at 530 something kilometers down and at 4. And where is this 10? Shallow 10. Oh, these are old. I'm sorry. I have these. I don't have this window bounded to our recent time range. This is all data. So that's what's happening in that area. Let's go to today and since yesterday. Yeah, we just have one. And again, it's at that depth that has been erupting, or that depth that and magnitude that has been very active over the past 50 years. Let's go back out of that. Let's zoom out, because those are the waveforms of the Earth itself moving around. Now, there also has been seismic activity in Iceland, and I don't know why it's not quite shown on that. This has been the seismic activity in the Reykjanes Peninsula. Not a whole lot, but definitely concerning, considering the land rise has it just keeps going. Like the land keeps rising. The land, like red is elevation here. These are the 4-hour solutions. Let's look at the raw GPS data. Look at many different stations. This is when we started to get concerned. And then this November 10th, it just really started to rapidly. Everybody's got that. Well, really, it looks like right before November. That honestly, that could have been on the eclipse. I think this was the eclipse. Yeah, November, and it's like 3 days before. That was the eclipse, guys. That was our pre-Halloween Saturday night big eclipse. Something happened. Something shifted. And then we've got this big buildup all the way to the December 18th. And we are building up to where we were pre-eclipse times. Honestly, you see it, you see it start at the first eclipse. That I'm talking about eclipses like in October of 2023. We saw earlier in the second weekend, there was on a Saturday, there was a new moon in Libra. And that was going to be the first of our Libra Aries eclipses. And then the final eclipse in the Taurus Scorpio series of eclipses happened as a full moon on October 28th. And to me, it looks like this uptick, this like inflation that led to the big November inflation happened. The inflection point looks to be on here, mid-October. And then there was an event right at the end of October that I think this is depressurizing the magma chamber, probably. This is when it started to build the dike underneath the entire peninsula. And this is the December 18th eruption. And this is where we are now. And it looks like it's even increasing in the rate at this particular one. Most of them were getting back to where we were on the December 18th eruption, but we're not where we were on the October 28th depressurization. I'm calling it that because I'm just making it up. I think that that's what happened. But, you know, you can correct me in the comments. If y'all think I'm wrong, please leave a comment. Please leave a comment and discuss, because I'd love to. Please leave me a comment. I'm very lonely. Drew, my toe cold. I stole your song. Okay. So that's what's happening earthquake-wise. And magma-wise. Also, I haven't talked about Campi Flegrei yet in Italy, but I have a feeling something's going to pop off there. And by I have a feeling, I mean a lot of experts have been talking about it. I'm warm. Are you guys warm? It's hot in here. Let's see. GFS model. I like to go to the 500 millibar height is the level of non-divergence in the atmosphere. What that means is kind of is it the tropopause? Hold on, let me look that up. Around 600 millibar, but I think that the 500 is a better. From divergence to convergence and vice versa. Basically, if it's sucking in to go out or sucking in to go out. The 500 millibar level is where we've gone from one version from like suck to blow, basically. Like the bottom is sucking and blowing and top sucking and blowing. This is the area where you can see the best average of what's happening above and below. Not like really an average, but kind of that's a great place to take a horizontal slice through the atmosphere to see what the whole vertical storm is doing. So here, I'm starting it at forecast hour, but you know, we're doing a rearcast here. We're doing a review here. We're not forecasting. We are rearcasting. You want to see my rear? You want to see my rear? We're rearcasting right now. We're rearcasting. Look, you're seeing my butt. I'm broadcasting my rear. That means that we are looking backwards in time. We're looking backwards in time to see. Wait, look, I kind of matched the 500 millibar vorticity map. We're going. Oh, wait. I guess that would be, we're going backwards in time. Look, I got a storm on my backwards in time. Okay. Anyway, sorry for me being goofy. I just feel goofy and silly with y'all. I just don't know what I would do without my little viewers. I don't know if y'all, I mean, it says 0 viewers, so nobody's here yet, but God, so soon there's going to be people down in the comments, and I'm looking, I'm watching my comments every day. I hope you guys are doing something there, because I'm looking forward to meeting you. But here it's me, Cloud, just back in January while nobody was watching. So when you're watching this in the future, it'll be like, wow, they were trying so hard for no one. Okay, so let's march back in time for this Rearcast, because we can see this is the big bowling ball of air. I've said that so many times, but like I just think of any sort of even slightly cut off low as a bowling ball of cold air, because it sinks. It just goes whoo. There's something called isentropes, where there's a type of map where you can look at the lines of even entropy, and that's a good way to, like, that's a good analog for vertical motion in the atmosphere, and things tend to just kind of like roll up and down the hills of that. And I think that's where I think of this as a bowling ball, because like once it starts to sink the entropy lines down, it just feeds itself, and it's like the heavier and heavier it gets, the colder and downer it goes. Really what happens in the atmosphere is a density transition between the heaviness of Earth and the lightness of outer space. And weather is the horizontal and vertical motion of densities rising and sinking. So, like when we're getting this big, cold, dense air, we are sinking down into matter. Now I'm getting metaphorical and talking a little bit like a Gnostic, but like I think of cold air and lows and sinking motion as densification of the spirit into matter, into flesh, the incarnation, the coming down into earth. And then rising air, hot air, is coming out of this earth, bringing with it what we needed to transform and transcend in order to reach up back into the spiritual world. What do I mean by that? I mean, this big old hunk of snowstorm is sinking down into matter over the US, bringing down something from the upper atmosphere to us. And then as it dissipates, it'll rise back up. But the storm is an interesting, I wonder if I have something for warm air advection and cold air advection on here. Well, I could do the dilation axes. I think OW, that's Obluco-Weiss dilation axis. So let's go to a different one. Do I have... Oh yeah, that'll be what I want. So this will show you where our divergence and convergence is, where I was talking about the sucking and blowing, and this kind of shows you what I'm talking about. Okay, so this green area is our, it's not exactly this, but I'm going to say that it is where our convergence and divergence is. It's gradient dot Q function. But I'm just going to use this as an analogy to show you that if we've got big low pressure out front, we've got the divergence, and out behind, we've got the convergence. Let's look at if I can get any. Oh, I bet that. I wonder if Cape is. No, that's just showing. This is why we're having. This is why Ryan Hall, y'all, is going live later tonight, because there is a significant chance of very severe thunderstorms throughout Florida and North Carolina tonight. Because I'm just gonna step through. Well, this run doesn't have it coming through the Carolina coast as much, but there is a lot of. Okay, let's go to. I want to see this. Yeah, I like looking at the potential vorticity units because I feel like this is the one that I can most easily see as the fluid. So we had this snowstorm. I think they're calling this one Finn. I think this is being called snowstorm Finn. And this is swinging in here. Finn swings in here. This is all analysis still, and really dumped a lot of snow up here. And, you know, right here, there was a earthquake. Very interesting observation to note that there was an earthquake here today. Swinging through. All right, now here's where we are at analysis. Look how beautiful that is. That is just chef's kiss of a reaching down, scooping up arm. That's a arm that scoops things up. Like is it this way or this way? Oh, I can't do it. It's a this way. It's reaching down and scooping up. It's reaching down and scoop. Oh, there we go. That's my arm rotated the right way. Scooping up the warm air advection, scooping up the warm air and dragging down the cold. And let's see, as we see, it wanted to cut off an earlier, like a week ago, it wanted to cut this off completely, but we're still pretty connected to the cold air. But man, that's almost wanting to swing negatively. I wonder if they have it tilting negative. No, it's pretty perpendicular the whole time. There's the negatively tilted trough. So this is when the scoopy action is done, and whew, like that last little, I think of it as like if you were in the pool and you were doing like scooping water with your arm, the negatively tilted trough would be that little bit of your fingers at the end that just go like splash the warm air advection up into the New England coast. And I've been talking on stream about it. I think that the warm air advection is the killer of these storms, really. Usually it's the feeder, but we don't have enough cold to come back down. Like you see how we don't have enough cold to turn this into snow right away. Our machine is breaking down. Our machine is overheating. So let's see what else we got. And then they've also got another snowstorm forecast to come through, Jerry. Let's look at Jerry. But yeah, you see it. It really, this is what this like tilt of going from here through to the negative, from the positive to the negatively tilted trough. I bet right at the vertical, we are going to see a lot of vorticity. Because like this is where we would get those straight line winds. Oh man, that is just going to be zooming across. Just absolutely booking it. Yeah, we're going to have some pretty big winds. Pretty big snowstorm too. I think this one will actually be, so this is our Tuesday. The big scoop up dramatic resolution of this drama. And then we've got right behind it, there's going to be another winter storm, and I think they're calling it Jerry. Now, I don't really know what all these percolations are, but I don't know. This one doesn't look quite as bad as Finn. Well, this has a big cold polar blast behind it. It's not as cut off lowy as Finn, but I think this one actually has maybe more potential to bring snow because it looks so much colder. Like, oh man, look, that's a beautiful spiral. And that's a negatively tilted trough. Like, very negative tilt into, again, that waveform I was talking about with the under the Fiji Islands. That's what their tectonic plate looks like. This is how the tectonic plate is moving. It's going like, so you see where there's divergence and convergence all around there. Okay. That one is definitely going to be more of that'll be this weekend. So this weekend storm looks like maybe more of a snow chance for the south. Perhaps we'll have a little chance of snow in Southtown. But then all of those storms go back into Canada and remerge. I don't want to sounding. Okay, I don't want to get distracted on the weather too much, but let's look at the polar region with this, because I want to show you this. Okay, there's Finn scooping through. Okay. Here's what already happened. There's Finn scooping through. And here's Jerry. But you see Finn go into here and start its own spin up lobe. And we are just honestly wasting our last little bit of polar air. You see how badly deformed this has become. I wouldn't be surprised if we didn't even see any blue next year. It's just fascinating to watch spiral around what actually happens versus now we're in forecast hour, and there's like, it's wanting to do 3 gyres, but when you go to the 10 hectopascal level, there's only 2 gyres, so it's kind of like deforming. Anyway, kind of a big bust for meteorologists who predicted snow in the south, and kind of a disappointing snowstorm for those in the Northeast who are used to sticking. But I think the Midwest and the plains really are getting their like good heaping helping of snow. It's just that the coastal regions and the South have not really gotten their same good winter weather treatment. All right. Oh, here's where I was going to talk about. This is like the shapes of fronts and stuff. I've got turned on 500 height absolute value, the Cape and Cinch, which I wonder if this open. Yeah. Cinch is convective inhibition, releasing buoyant energy. Cape is convective available potential energy. Maximum buoyancy within 300 mil. Okay. This is, Cape is where you're putting the lid on the pot and it's going, and then Cinch is when you take it off and it stops boiling as fast. So what's in the green and red here is actual IR satellite. And what's in the blue here is the 500 millibar height. And, well, right. Yeah. And this, where they've got shaded, is the Cape and Cinch. So really what I wanted to show with having the height on there is that the center of the low aloft is out behind this line of storms. Let me turn this off real quick so we can see what's happening in the Gulf. we're not really seeing it very well, but let me see if I can refresh if I get, yeah. This is about to be a big squall line swinging through Florida. Let's turn that back on. But so you can see here where that big line is about to form. That is where it's about to sweep through. It's about to do that big sweep through, and through all of that lower level buoyancy, which is Cape, like the air down there really wants to get picked up. And this is an arm scooping through the pool going like, pew, let's scoop you up. Pew. And I don't know. Well, we're going to have to watch the Ryan Hall y'all channel later tonight to see what he's got at like to see what happens. So speaking of weather, let's look at the solar weather. Because as we go up into the higher elevations, I did the nosedive yesterday. I did the going down into the earth from the sun. This is our going back up. Solar flares last night. Definitely had a slight solar flare when I was live. And then also again when I woke up and did shit. Did stuff and went to bed. And when I woke up today. So let's look at real-time solar activity. That 3536 is almost out of our view. It's down to only 13 sunspots, and it was at 24. Solar proton flux looks interesting. No, it doesn't. It's still in the very low side. Solar flares. Not seeing much. I mean, there's a big dark spot. And again, it's in that shape of a crashing wave. It looks angular, but it's really a crashing wave. These are all waves. The sun is the big wave machine. Probably going to get a C flare soon. Let's look at where our auroral activity would be. Low KP index. Well, not as low as it's been, but not that bad. Not that bad. Auroral oval. Today, y'all are just seeing what I do to prepare for the stream. Scooching more towards and this is an interesting one to look at with our polar view of the tropical tidbits in mind. When you think about the breakdown of the polar vortex, this is based on roughly circular flow. So really the path that aurora could take should be following that PVU, 2 PVU map, potential vorticity units, that I had up. Not looking great for aurora right now, but it's the latest CMEs. Had 2 today. Let's see. They looked like. Whoosh. There it goes. big flare launch. Coronal mass ejection. Looks like it had a halo on it too. And let's look at this other one. All right, that looks pretty similar. Let's okay. Yeah. Let's this one says partial halo. Let's look at the partial halo one. I haven't been showing our coronal mass ejections because I'm not a solar weather scientist. I don't know exactly what they mean as much. But God, look at those big blasts. Those big old sun farts. Sun farting it, shitting its little particles all over us, shitting its mass everywhere. Yeah. Been pretty active though. But as you know, I believe that the sun is an average of what's happening in the planets. So let's look at the stars. What's happening right now? Well, currently we're on Monday. It's a moon day. We're not in the Venus hour anymore, though. We're in the Mercury hour. Yeah, we're in a Mercury hour, a moon day. We're in a Mercury hour, so I feel like I need to communicate effectively and beautifully. Let's see. What's popping out? Oh, Mars is sextiling Saturn, so good day to get shit done. I'm doing it. Guys, I'm doing my best at getting shit done and not fucking it up. Moon is happy. I feel like the moon is happy here in Sagittarius between Venus and Mercury. It's about to go visit Mars and the big like this is the pregame for the work function. I see Mars, Sun, and Pluto in Capricorn as the work party, and Venus, Moon, and Mercury in Sagittarius as you kikiing with your friends before. And after this work party, we're going to get fired. No, we're going to run into Saturn and Pisces. Really empty Aquarius right now. This is probably the last time we'll see empty Aquarius for 20 years, like very long time. And it looks like to me, oh yeah, we've got Mercury squaring Neptune right now. So I might not be speaking my dreams into existence very well, or at least I gotta try to speak them into existence. Use your voice to make the dreams come true. That's what I'm getting from this. I said earlier that Venus in Sag is the pop star, and I still feel that, and I feel her applying to this Chiron that just got squared by the sun. And I feel like this is, if this was imposter syndrome, this is trendsetter. Yeah, that's trendsetter. Not too much else to talk about. I've already talked about Rearcast. I went from the Earth all the way up to the sun. Oh, I wanted to see if my volcanoes, if we've got any good volcano activity. Yeah. All right, right, I got to bookmark this. This is one I didn't have bookmarked, but let's see what happened today. Semeru volcano. Indonesia. There were also earthquakes in Indonesia too today that were at that, again, that classic 4.5 magnitude, 10 depth here in Indonesia. I like that I'm going from sun back to volcanoes, because really it's the sun that activates the volcanoes in our Earth. And anyway, what does that say? Southern Sumatra, Indonesia, at Andaman Islands, Myanmar. What is this? Deep one. Sea of Flores. Let's come back here. You see, my targeted ads are for inflatable beds and solar power batteries. I don't know what that means, guys. I don't know what, maybe they think I'm a prepper. That would be crazy. But maybe I just put some of these things on my wish list. And down in the description, you can actually go to thingstogetme.com and get me some improved equipment for my studio setup. So that would be really awesome if you did. Okay, we've got explosive activity in Indonesia, Java, volcanic. These are all volcanic ash advisories. So the mountains are smoking. Explosive activity continues. Guatemala and Indonesia, Colombia. No real eruptions. Here's what we got. I mean, there are the ones in active eruption still, but I think really we're the ones that are in active eruption, like at least we know they're erupting, but the ones that are in minor activity are the ones that are a little bit more unknown and a little bit more like, could erupt. Could be. This is interesting though. Mount Erebus, because it won't let me zoom in there. I wanted to show you the Ballini Islands. The other day, there was a big earthquake down here at that 4.5 magnitude and 10 kilometer depth. There was a swarm right here. And I feel like the energy went from Japan out this way and also down this way into Antarctica. And I'm not going to dwell on Antarctica, but it's a place that a lot of people who are alive don't know anything about. But there used to be a whole forest here. It used to be a whole continent. Then it like shifted into the cold part. It's in Exeges. It's in the frozen state of the sleeping king that's slumbering underground for it to rise again, like sometime. Again. Sorry, I got distracted thinking about Antarctica. But the Ballini Islands are right. Ballini. I don't remember. I don't know how to say it. Right over here. And they had a little, they had a little something going on recently. And this is where Mount Erebus is. And it is actively erupting. So interesting to say the least, that got eruptions up here They swirl and they come down. And then where should this other peak of, here, I'm going to show you where I'm talking about. If this is a wave, where's the other part? Right here? Right here. Now remember, we're getting flat. This is close to the center of the Earth, so we're seeing a good representation of it. But here, we're not seeing this in stereo. This is why I like stereographic projection of the map a lot better, because it's misleading to see, oh, it just kind of goes around. I think that we would see a lot more waviness. Still dropping off those 4.5s all across. I mean, it's just really very clear to me that these convergent faults are susceptible to, wait, what was that depth? I don't think that was part of it because it was a little further down. Again, oh, interesting. We had a 4.3 10-kilometer depth over here off the coast of British Columbia. Yeah, that is interesting. Vancouver Island. In Vancouver, you say? Vancouver. And that was, oh, again, right at one of these wave crests. Yeah. You love to see it. Let's take a look at this animated. What are the quakes animated looking like? Let's get all of these and these at the same time and then animate. So we're bouncing around in here and then we're here. These little tremors up in Alaska, very normal. Yeah. I'm going to scooch it down to our target zone here. And then reanimate. I'm not showing Reykjanes or Iceland on here, but I think it's fine. Really want to see here, 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 here. Let's loop this so I can get a better understanding of how this is traveling. Looks like a big snake or like a sea serpent just coming up and like hitting the door frame of the crust of the earth, like really trying to surface, because this is shallow quakes. But did we have another one in Japan today, just now? That's wild. God, it feels like we are on the precipice of understanding how all the waves work together, but we're still held back by materialist science hangups. What do I mean by that? Can you really explain waves with material, or do you have to do analogies? Do you understand how to integrate, or do you do the Riemann sum? I think a lot of science right now is kind of chunking up knowledge into discrete units to count, and then we'll count them all together like a Riemann sum. But a truly integrated theory of science will not discretize the curve of knowledge. It will independently at each point evaluate where the curve is and how far we are from the baseline. What I'm saying is, having people who are scientists and aren't scientists is like chunking it up into discrete bits. And we need to let everyone think about the earth so that we can see what their perspective is from where they're standing. We don't have to chunk things down into bits and groups if everyone is their own bit and everyone is their own group. I hope that is, we're all part of the human machine brain system together. And we need to be able to be ourselves. That's just it. And if you get chastised for something that is being yourself, then that is just a sign that you are in the wrong spot. Because you are never the wrong self. You are just in the wrong place. And it's not even the wrong place. It's just not going to give you the results you were anticipating. Let's go to null Earth real quick. Have this on in the background. What are the winds like over in this area? It's also winter at the South Pole, so it's very interesting that there are all these. Look at all these waves. Look at all these waves making those natural shapes. Very natural shapes. gotta do this again. I gotta get my attention back into space. And let's do a little card reading. And I'll get a card for everyone here today. I got this one yesterday. I am selfish enough to want to feel good. Feeling good indicates your connection to clarity, wellness, and an abundance in all good things. Feeling good is your most natural core belief. Yeah. Feeling good is my natural core belief. All right. Love you guys. Wow, it's been a whole hour. I really went off on this one. Moon day. Let's be a little extra. Have a great night, guys.